This is going to be a little bit of drinking out of the fire hose session. There's 60 slides here that I want to squeeze. Yes. That I need to squeeze into 30 minutes. But there's a back-to-back session. The next session is about like an actual procedural memory. So maybe we will shorten that one a little bit because that will be quicker to demo. So yeah. So what is agent memory? If you look a little bit around, you see that Anthropic, for example, doesn't really have a memory system implemented in Cloud Code, and there's a reason for that. I think the reason is just that it's a really complex thing, and memory systems really need to be tuned to your specific use type. So, but it's kind of useful to understand like what are the basic principles of memory systems, and so you can actually evaluate them yourself after the session, hopefully, that you understand when to use which one, and also how to build one yourself. So, yeah, we're just going to go over this, the main types of agent memory, what types does your agent actually need, some memory systems that exist out there. We're going to have a look at them, and we'll talk about evaluating them. So there are 4 basic principles that you have with memory systems, or basic types. One is obviously the working memory. It's typically what you have in your Cloud Code session, what the agent currently knows. You have episodic memory. That is memory that tells you how to do things or how you did things, basically like a log. Your agent did this and that, like a log file. You have semantic memory, where you might store information about your organization, about your project, those type of things. And you can have procedural memory. That is things on how to do stuff, like muscle memory, for example, is procedural memory. You don't spend a lot of time reasoning about it. It's very easy to execute without re-reasoning. So, yeah, so let's just go over them very quick. So working memory is, what you have currently in the session. That's basically it. That's all you need to know. And it just enables real-time decision making. You cannot do anything without working memory, basically. And that's what you start with when you have a Cloud Code session. You install it, you run it, you immediately have working memory. Then episodic memory, that is pretty much what we just said. It's the log files. You analyze your log files, you can see what happened, what did the agent do, this type of stuff. You can also index it. You can put it in the vector database so that you can query it later. You put it in log files so you can search your log files. It's basically a trace of what the agent did, and during its working sessions. The semantic memory, already thought a little bit about this. This is typically like knowledge bases. If you have Obsidian, for example, that's your knowledge base. That's a form of semantic memory, where you just put everything in it. It's not necessarily related to any current session, but you can query it to get context into your current session. Typically, you find that semantic memory is really curated, human curated very often, and it stores facts, relationships, heuristics, kind of world knowledge that you might need. And procedural memory is to really enable like efficient consistent execution of tasks without re-reasoning. That's the main point of it. And later, or the follow-up session will show you an example of that. You can have this as skills, for example, your Cloud file that has specific instruction on what to do. It's the simplest form of having episodic memory, or procedural memory, sorry. And yeah, it's more static. You don't evolve it that fast. It's another aspect of it. Whereas the episodic memory constantly gets updated through what the agent does. There's a quick summary table. I'm just going to skip over that. And now the thing to know is that not every agent needs all classes of memory. And the best practice is to start with the smallest memory system that you can. And only to add stuff on top when you see that your agent doesn't do what you want it to do. There are a lot of people who start with, oh, let's install like a memory system. We found, I don't know, mem0 or something. It sounds awesome. Let's just use that. But that's found to be the wrong approach. because you don't actually know what your agent needs. So just putting like a whole system in place and hope that it solves your problem that you can't define is not going to work, right? It's a classical example of over-engineering and adding system complexity when you don't need it. Now, long-term memory is typically something that we refer to when we talk about episodic memory, semantic memory, and procedural memory combined. So that is memory that gets persisted over multiple sessions. Obviously, that's everything that is not working memory. And you can have agents interact with the memory. Typically, that's explicit through retrieval or tool call user, like calling an MCP to do a RAG or something like that. And yeah, most systems, they just combine these approaches, but to solve very specific problems, obviously. So, which type? Well, any questions so far? Yes. Procedural memory. Sorry, episodic memory. I keep. Yes, it's well. Well, you can have event logs. You can have structured databases. So this could just be log file on disk, or combination of both. Yes. Typically you index your logs as well, and as soon as you do semantic embedding, you have a vector database. So how you store that isn't as important as how it gets generated. So yeah, which types does your agent need? Well, we start with the minimal, with the simple core, and then you just add components that provide clear value. So the baseline is typically you need working memory, otherwise you can't do anything. That's your Claude session or your Codex session. Now, if you want procedural memory, that's basically when you add skills, right? When you have things that you do repeatedly over time, and you just want to save the effort of typing, or you want to make sure that there's some kind of quality control where you have clear instructions that you want to share with the team, you start adding layers to your procedural memory, or like instances to your procedural memory. Now, there are other components besides memory that you need for an agent. Obviously, those are the reasoning actions, the grounding action like tool call usage, and the decision making. But that's all what the LLM does automatically for you, or your harness does for you. Your harness provides the tools, the access to the memory, and then the action is what your agent does with those tools. This is more like conceptually what is required for an agent to work. Right, so if you want to decide what type of memory you need, you can start with this. So if you start task like a short horizon and a stateless task, like a single prompt that you will never use again, you don't really need anything beyond like working memory and obviously like reasoning model. If you span multiple sessions, you probably want to add episodic memory to remember things that happened in the past. So maybe you don't want to repeat mistakes. You add logs for that and give your agents in different sessions access to that information. If you need factual knowledge or user preference or a world model, then you need to add semantic memory. And if you expect to get better over time, you probably want some mechanism that goes over your memory and distills it and updates maybe the semantic memory or procedural memory, like your skills or something like that. And yeah, if you have like a very complex agent that does planning of those things, then you start to work more on the reasoning side of your agent instead of the memory, right? You can do things like, I mean, those are, right? You will probably change your prompts to make that happen instead of the memory, or use team of agents and all those kind of things. Now, the next step is, well, if you want to know whether you need working memory, you can use this template, or if you need semantic memory, and I'll post all of this on Slack so you can use this. But there's a very easy evaluation matrix where you can just go through, oh, do I need this? Yes, yes, yes. It becomes like a checkbox exercise, and it tells you which type of memory you probably need. Sorry, just skipping over because of time. And stop me if anything is anything in more depth. There's also other types of things. For example, if you need to do retrieval, like very specific actions, you want to probably add like a rag style lookup. And you want to have access to your long-term memory, you probably want to add a rag system. If you want to have learning in your agents, you probably need to implement these reasoning steps where you do reflection, distillation, all those kind of things. And if you want advanced grounding, that means you need to know more about the world. You want to give it more tools to be able to reason better. You just have to add different tools to it, right? And then there's the fourth angle to look at, what the agent needs is kind of like, okay, what type of action does it actually do, right? Like if React style is, you give it a prompt and then it thinks about it and then it acts. That's a basic, very basic. If you need to add reflection, which is then of course also reflecting on memory, reflecting on episodic memory, that's then falls into the category of medium decision procedure, and then advanced is obviously, if you have very exploratory agents, you need to do a lot of reasoning and planning, but that is not specific to memory systems. So let's look at an example. A simple conversational agent probably needs memory only, working memory only, basic reasoning and grounding, that is, it gets some tools, and it gets an LLM for the reasoning. And a very simple decision loop, probably just a prompting or reacting type of style interaction that you have with a simple conversational agent. So when would you update this particular conversational agent? Well, if you have like a chatbot agent, you probably want to give it some domain knowledge, right? So what type of memory do you add? You can add semantic memory. If it's like a pizza ordering bot, give it semantic memory, meaning access to what is available on the menu. Or if it's a bot that does certain things, you probably want to give it episodic memory, where it can recall things or how things were done, things like that. Example 2 is a software coding agent. So you need the working memory, obviously. And you probably also want episodic memory to remember when things went wrong, so it doesn't repeat things. So you want to have logs. And you can add semantic memory, when you want to add the ability to, overlook larger parts of the code base, to reason across different parts of the code base. So you start to encode that knowledge so that it's easily accessible via semantic memory. So you can clearly see there's like an escalation of or leveling of the memory model. Another thing that helps with the coding is procedural memory. Typically, that's a skill library, and you also give it more abilities to perform actions, right? And those are then obviously the tools and the decision procedures. Then again, we're back into prompting territory and choice of model that will provide you greater capabilities. So that's another simple model: start minimal, working memory, code execution, grounding, basic reasoning via the LLM. Episodic memory, you add that when you see that the agent keeps making mistakes. You don't add that before. You see it makes mistakes, that's when you add that. Same with semantic memory. When the agent needs to understand your domain or your world, that's when you add semantic memory. And you do learning from, for example, episodic memory is when you want the agent to improve. So you mine the traits that the agent did, you analyze what went wrong, maybe you update the prompts based on that, etc. So that's then the learning actions that you can add on top of that as well. Here are a couple of other agent types. A research agent, for example, needs a working memory and semantic memory, obviously, to access, domain knowledge, because it needs to have facts and needs to be able to recall information. Personal assistant just needs a working episodic, maybe semantic memory, depending on what the tasks are of your personal assistant. A game agent, for example, might only need working procedural and episodic memory, meaning it will has patterns that it can execute via episodic memory, and yeah, maybe procedure memory to identify where it goes wrong. Yeah. So it's really simple. If you just decompose it this way, so just that's basically designed by start minimal, add only components when you see that the agent does things wrong. If you see your agent doesn't know about your domain, you need semantic memory. If you see your agent isn't learning anything from past actions, you probably need episodic memory and some learning actions. So you always go from failure to adding the next component. So you never over-engineer the system. And another thing is that updating memory is actually really risky. You can see when Claude Code, for example, updates its memory, you think, why are you updating your memory right now? This is the wrong information. Why are you storing particular this information? It doesn't make any sense. And it's risky because you basically perform like a lobotomy on yourself. Like you can take your brain out by overwriting memory. And so it's really risky. And another reason why you never want to over-engineer your memory system. Your memory system needs to be easily debuggable. You need to be able to change anything in your memory system manually by typing. Right? Otherwise, it's just a black box, and you don't know how memory might be contradicting itself. Basically what you end up with context rot, basically, that makes it more difficult for an agent to perform. So yeah, and you just make it modular. In that sense, it's very boring. It's just traditional software engineering. Right? So yeah, so there are a couple of memory systems, and if you take the slide deck and just put it in, I don't know, ChatGPT or Gemini, you can just put it in and say, evaluate me the memory system based on that slide deck. It will give you like feedback of what the memory system does and when you should use it and when you should not use it. Has anybody heard of MEM0? No. LangMem or any of the others? Well, maybe they're not that interesting, but what is interesting is they all have the different strengths and different techniques that they use to store memory and update memory. And these systems can be extremely sophisticated. But then the question is, do you really need that? Right? A typical answer would be no, unless you have a reason to add a particular feature. So when you evaluate your need for a memory system, you just go through the checklist. And if you want to find a system that matches that, you just see whether it supports it. Yeah, on the slide deck, there are also some recommendations if you want to look into that for creative writing, for coding engines. Yes. Yes, please.
So these memory agents, these memory stacks, they store information about the different types of memory. For me, it always translates into tokens, right? And
yes.
Are restricted how much you use. So how? What is the mechanism that because you can't send all the memory to the LLM because then your tokens are finished in no time. So what is the mechanism from memory to
the retrieval mechanism to get it back out from the memory, the relevant information? Yes.
Abstract that you send to the LLM, right?
Yes. So that's another science in itself. So you're opening another can of worms. That's actually a hard problem, and you can think about it as a search problem. How do I find the relevant information for the current task in my memory system? There are different strategies to battle with that. So one is you make the task very specific. So the matching with the memory that you have, for example, like a procedural memory, how to perform a certain number of steps is very specific and it's easy to find. And if you design a very general knowledge system, where maybe the information is hidden in a huge block of text and has to be distilled, that's going to burn a lot of tokens and make it more difficult. And with memory systems, you're constantly fighting this problem. And what the most effective systems do is they have the agent very narrow in scope, like they do one thing. let's say, code review agent or security review agent that knows exactly what things to check and what these things look like. So it's quite easy for that agent to pull out that relevant information from the knowledge base. It knows exactly, okay, give me OWASP top 10 and give me a list on how do we typically check them, right? So that'll be like procedural memory. And then you provide high quality context for your agent. But with, for example, if you have a word model in the semantic memory layer, you don't know how good it's going to work. And the only thing that helps to understand how well your memory system works is to really probe it, to have memory probes. So, for example, if you have like a long book and you put that into your semantic memory layer, you can ask very specific questions about the book. Maybe you start with facts that are very simple. Maybe then you start with more complex things that need to be inferred from the text that aren't written explicitly. And so you start to measure point by point how well does the memory system work. And the memory probes that you pick are the ones that relate to your specific use case. So not only do you need to know exactly what you want to be searching for, but you also need to know what the answer should look like. And so that gives you like a test suite basically of your memory system. And so that's the way you evaluate it. And then you hope it's going to work equally as well for similar questions. Yeah. So it's not an exact science. So here are some tells how you can tell whether your memory system works well. One is obviously consistency across sessions. You want to see that your code review agent does the same thing in different sessions. If it doesn't, probably wasn't able to retrieve the memory correctly. The relevancy and precision for retrieval is another measure. So if you can look at what your memory system returns, and you as a human can say, okay, this is completely irrelevant to the task or to that query, that's a tell it's not working well. However, when you see it fetch the right stuff, then that's a good tell. Another one is temporal awareness. If you have a timestamp memory like the episodic memory, which is typically timestamped, some memory systems have things where they have a decay of importance over time. So the information that was true yesterday is more important than information that was true 2 weeks ago. Maybe on the same topic. Maybe 2 weeks ago we wanted to have all configuration parameters written in lowercase, but yesterday we made the decision to make them all uppercase, right? So you can, evaluate your memory system whether it respects temporal changes of facts, for example. Yes, and efficient token usage is another one. You can burn a lot of tokens if you just feed your entire memory base to your agent again. Low hallucination. If you read through this reads pretty much like how to tell whether your context window has gone bad. It's very, very similar. And easy inspectability, that's really important. You need to be able to look into your memory system. Otherwise, you cannot debug it. And obviously, the opposite of everything I've just said are the tells that it's gone bad. It has amnesia, it forgets things that are clearly stored in memory. It finds things that are irrelevant when it retrieves from memory, contradicts itself, or the agent drifts over time, meaning, it interprets the memory different over time, etc. So, come again? Yeah, that's the international sign for everything's okay. And so practical ways to test the system. We already talked about memory probes. That's pretty much the approach. I already explained it, so thanks for that question. And there are some metrics that you can track. You can track them automatically, like retrieval relevance. If you have a query for finding something in your memory system and you have a result, you can actually measure the relevance. There are metrics that are sort of precise-ish, but not really precise. But that can give you like an indication. If you look at the relative score over time, how they change. Token efficiency again, success rate of the agent. So obviously the agent adds more complexity then you would have your own evaluated memory system, but those are all telltale signs that you can use to track performance. Debugging techniques, everything must be inspectable manually. That's your debugging technique, right? And yeah, so let's quickly talk about memory scoping, because there's this wet dream of engineering managers or CEOs or CTOs that you have a memory system that encodes the entire organization, right? And even on a smaller scale, on a project scale, you could ask, okay, what memory is valid across projects, or for even all my projects on my own computer? And then you could say, okay, I can scope it like all of my projects should have, I don't know, a specific style of a makefile or something, right? So that's set for everything. The danger is that, what if you have an exception? How do you encode that in your memory system, right? So you typically try to avoid all of that. You try to make it very specific for a specific task again. So this is difficult to get right on to have global or user scope memory. It's very tricky. You need to keep evaluating it. It's just dangerous and can be extremely messy. So if you do per project, that's typically much better. That's what I do. I solved the problem of when I switch between projects and I want to give the next project the same knowledge. I just clone parts of the project. So that's how I deal with that. I just clone, for example, all my guardrails, I'll just clone them. And or I take code, hey, we did this in that project, please copy that over. I trust that process more than having that in a memory system that retrieves all of it. Yeah, per session, I mean, that's the lowest risk. That's basically like your prompting session. You don't really need anything except maybe even only working memory. So, however, there are some recommendations. So if you really have to have like user level or global level memory, store things like user preferences, high level goals, those kind of things that belong at that level as well, but not like project level details. And project level, you have like history of the project, maybe best practices for working with the project, all those kind of things. And then session, it's just working memory. There's really much to think about. Okay, gonna skip over these systems. So for scoping, yeah, it's the same approach as for memory systems. Start small, start with a session, expand when needed. Try to avoid anything you don't really have to do. There's no point in encoding like global memory if you didn't see that your agents need that. Okay, cool. So now let's, maybe the last 2 minutes, we just go through the evaluation. So one thing that I see that's very popular are these popular benchmarks. You can see like SWE-bench, the all sorts of benchmarks. People use them for evals, for all sorts of stuff, for software factories, etc. And you can also use them to evaluate memory systems. And those are quite good, but they're different from very task-oriented benchmarks that rely on the tasks that you actually perform and not the tasks that are in these public benchmarks. So typically what you see is with these big published benchmarks, they have like a standard number of tests. But the problem is it's equivalent to like a crash test of a car. It does that specific crash test, but what if you build a motorcycle, right? What if you build a boat? So it can give you some general information of how your system performs, giving those specific tasks. It's sort of like an IQ test. It only measures what is tests, right? But you don't need to be a genius to be, well, you can have other levels of intelligence that are not reflected in an IQ test that make you very proficient at other tasks, right? So you could be musically gifted, for example. Does it show up in a math IQ test? I don't know. Probably not, maybe so. So these tests have their place, but it's really more to showcase to the world, hey, for marketing, hey, our system does that. It's able to perform well on this test. But it doesn't tell you how well it's going to perform on the actual task that you give your system, right? SWE-bench, Web Arena, so a couple of them. Now, If you're really developing stuff, the best thing is to just build your own test suites. Like I said, you do the memory probe thing. You come up with the questions that you expect the system to answer based on the memory. You add consistency tests, basically regression tests for your memory system. And you can, you can also use the idea of the, yes. Yes. Yes, so it's probabilistic. So what you do is you run the test over a long period of time. You run a lot of tests, and it gives you general direction, right? Yeah, pretty much. It's like a particle detector. If you want to know where the particles are coming from, if you take 3 particles, you never know. So you need to have like a range of particles to measure them to get an idea, okay, they're coming from that direction. Same with these tests, right? So it's a very data science approach where you try to have enough tests and you observe what the trends are. You can probably see like failure patterns where memory probes continuously fail, maybe of a specific query type. That gives you a hint of what you need to improve in your system. But yes, it's very much a statistics-based evaluation. In terms of token, I cannot run my business based on probability. Well, you have to. The probability if you get a customer, probability that you're gonna get a loan, probability you find good employees, it's all based on probability. There's nothing that's not based on probability. The thing that is weird with these LLM systems is they're probabilistic in nature, but data science has these tools already developed to deal with that. And that is, you can have like statistical tests that tell you, the probability of this not working is below 1% given the statistical evaluation. So, right, it's the same thing as like an insurance model. It's not. Yes. It depends on how many tests you have. Like if you have 1,000 tests, it probably costs you like $20 or $30, right? Yeah. Oh, so you're thinking about like something where you can have like 100% test coverage? Yes, it's not possible. It's also not really desired. So the tests with AI have typically worked this way. So you test the things that your system should do, like you create your queries, your memory probes. You observe if they work. Like if they work most of the time, you're good. If they start failing, you investigate why, improve your system so they stop failing. So you always iterate more towards a system that behaves more the way you want it to behave. So all what you do is you start from your use case and check whether that is fulfilled, that querying the main system works. And that's just how that works. It's just a statistical evaluation. Obviously it's more expensive than running deterministic tests, but you will never have 100% coverage because you can have an infinite number of inputs to your system, right? Queries, it's an infinite number. And the best thing you can do is pick those queries that belong to your use case, make sure there are no major failure modes in that use case, no major defects that happen there. That's typically what you do. And as soon as you discover like a user query that didn't work, you add that to your test suite and add on to that. It's pretty much an ongoing process. It never stops. Sorry for that. No, it's fine. I'm not even talking in technical terms.
statistical test and say, okay, if it still scores 80%, I'm fine. Does this mean that this is suitable for Amazon kind of business, like they are advertising the product or whatever, but it is not suitable for a specific medical business?
Yeah, for then you need medical queries. Like you will never build a general purpose system. You will always have to do your specific evaluations for your use case. I mean, you can build a general purpose system, but you're still going to evaluate it on your specific use cases. That's why these public benchmarks are pretty much worthless to tell you whether they work well for your use case. They give you like a sort of rough idea across standardized tests. But yeah, just to close it real quick, public benchmark often red herring. So yeah, so expert typically spend the time, really measure what matters, the type of scores that matter, end-to-end impact, right? Does it memory lead to faster task completion of fewer errors? So we're measuring all of those things. Yeah, public benchmarks don't have domain knowledge that you have, so you need to include them. And yeah, and also like if you have full observability, you also have the ability to inspect and debug your system much more easier. And yeah, and you can combine automated method with human judgment, right, to make that happen. So that's pretty much it. I have a list of papers and links attached. This presentation is based on the Koala paper, which is one very influential paper on AI or agent memory. If you want to dive deeper, you'll find that in there as well. And yeah, I added a couple of links for specific things, benchmark, etc. So if anybody wants to look into that, that is there as well. Thank you very much.